Hi, welcome back to another episode of Azure and AI at the Edge. I do hope you enjoyed my unboxing of the Azure Percept DevKit a few weeks back. Today we're going to put that device to some use with a real use case, and we're going to do it without writing a single line of code. So let's have a look at what we're going to build and then dive deep into how we're going to build it. So as you saw there, that was my own little version of American Sign Language. We're going to go and create inside the Azure Percept Studio now a prototype. So the first thing we're going to do is we're going to open up the portal. And you'll notice here I've got various ways to get started with sample applications. I'm going to choose create a prototype because I know exactly what I want to do. Now under here we've got some more sample projects we can use, and we can actually create a vision prototype, which is the one where I'm going to be able to train the model the way I want on the images that I want. So the first thing I've got to do is give the project a name. We're going to call it Learning American Sign Language. It's actually going to use some of the cognitive services inside my Azure subscription. So once I finish typing the description, you'll see I'm using the Azure cognitive services already. Next thing I want to do is help the project understand that this is classification or detection, and then balance between accuracy and latency. With that decision made, we can now move on to connecting it to our IoT hub that we created during the unboxing event. It's important that it has access to the IoT hub so that it can stream the telemetry to that device. Now this is the web stream that we saw before, and of course you can see it's got a generic object detection happening at the moment, which we actually want to customize now to do our own object recognition. Now the first thing we're going to do is capture some images. The great thing about Azure Percept is it has this auto capture feature, which will allow you to operate the device hands-free and capture a set number of images in a particular period of time. I'm going to capture the images manually, and basically what I'm going to do is start feeding it some of the characters from the American Sign Language, such as the character for A that I'm holding up here now. And I'm going to give it different contexts to capture the image under different circumstances, and hopefully train that object recognition a lot better than if I was to just capture a few static images always in the same place. So I've got to teach Azure Percept a whole bunch of characters from the American Sign Language, and I'm going to speed up the recording here where you can see other characters being taught and fed into the device for recognition. Now with all those images uploaded, the next thing we've got to do is head over to the custom vision portal so we can tag those images and train our model. Now this portal is specially geared up to help us manage all of those images, and you'll notice they're all untagged at the moment because it doesn't know what each picture represents and what do I want it to mean. So I can load up one of the pictures and actually tag the area that I want to be recognized and say this is the letter A from my American Sign Language. Now I'm going to do this for a couple of images, and you'll notice one by one I can go through each one and say this is the letter A in different contexts. As you'll see, this is a little bit of a laborious process, but there are a minimum number of images in order for the model to work. And the good thing is the portal will make life easier for us as we move through this project, as you'll see later on in this video. So we jump back into the portal and all the images have been classified and I have no more untagged images. My American Sign Language is starting to take shape. Now I've got two options to train the model. I can use some advanced training where I can limit the budget of how much Azure I want to use inside my cognitive services, or I can use the quick training option, which will get me started very, very quickly to get some results out of the box. After just 10 minutes of quick training, you can see my model has performed quite nicely. I've got some nice KPIs here which show me the precision and the recall of the model that's been trained on those images. And of course, these are all going to be indicators of how likely it will perform well when I put this into production, based on some of the training images used on that model that was created. Unfortunately, I've got a bit of an uneven distribution in some of the letters that I scanned, and so I'll need to fix this later on in order for the model to perform even better. Now, because I'm quite happy with iteration 1, the first thing I'm going to want to do is publish that model so I can expose some endpoints which will allow me to test the model. Now I could use something like Postman to test the prediction API, and that could be quite easy to do, but for somebody who's not a coder, the easiest thing to do is use Quick Test. And the good thing with Quick Test is I can upload an image of my choice and then actually see how well the model is performing. You can also see that the model is giving me varying levels of probability in its prediction, so I can tell how well it's performing. And through this initial test, it's actually done a pretty good job of understanding the alphabet that I've taught it so far. So after a couple of iterations, I think the model is now ready to go, and so we should just deploy it to the Azure Percept device. And as you can see now, the Percept device is loading the new model, so it can do the inferences at the edge. And it's performing, as expected, pretty well. Good deal of accuracy here, and able to differentiate between the U and the R, which is pretty good. So now if you want to have a look a bit deeper, let's go under the covers, as they say, to see how that American Sign Language is being transcribed. The first thing I want to do is go in Percept Studio and have a look at the device. Now, the device, being the Azure Eye module, will give me some telemetry. And that telemetry is simply a JSON object which is streamed across every so many seconds in order to provide me the information that the Azure Percept is actually viewing. And as you can see, looking at it closely, every time an object is detected, I get a little JSON body which tells me there's the word love been detected, and there's the bounding box as well as the confidence that it knows that that is the word love. So let's dig a little bit deeper to understand where this telemetry is being sent inside my Azure subscription. We know that the Percept device was tied to an IoT hub, so the first place I'm going to look is inside IoT hub and the one that's called Percept. And if we have a look over here, we can see that telemetry is being sent to this IoT hub pretty regularly, and it's quite busy. And we'll also notice that the events have been subscribed to and been collected by Azure Event Grid. And I've got one for the eye and one for the ear. Now, we can tell the difference between the two because the messages being sent are actually being stored in an Azure storage queue, but I'm actually doing some advanced filtering in order to minimize the amount of noise that we're hearing here. And of course, this is using the message begins with to actually identify eye data from ear data. And the next thing we're going to do is head over to Logic Apps, where we process that Azure storage queue in order to make the extraction of the body into some more readable form. So the first thing I'm going to do is whenever there's a new message received, I'm going to take it off the queue and I'm going to pass it using the JSON schema that Azure Percept is using to send me that telemetry. And once I've got the message and unencoded it from base 64, the next thing I'm going to do is actually extract the label, which, as you remember previously, said love or any other letters which were being sent. And then through a little loop, I'll actually take out the data and push that back to another queue, which will just be plain text. So what I've really done is taken the telemetry apart, parsed the data, and pushed it to another queue. So at this point, it's easy now for the Power App to just pick up that data off the queue and process it. The Power App is pretty simple. Again, it's a low-code, no-code environment. And I just created a very simple screen with a text box and a timer. The button is just there for clearing. But you'll notice inside the timer, every time the timer event goes off, which is basically every second, I'm going to pull some information off the queue by reading the messages of those Azure queues. And as you can see, that is the queue which has the plain data on it. So that's all there really was to reading the data. If I run this app, we should be able to pick up the data off the queue. And this is not exactly the same data we saw before, but as you can see, we're reading the queue data without writing any code, which isn't much different from an Excel query, to be honest. So there you have it. In just under 10 minutes of training and 10 minutes of video, you've seen how you can take American Sign Language and transcribe that using a Logic app and Power Apps into something that everybody can read. I do hope you've enjoyed this video, and if you did, please subscribe to my channel Azure Jedi, as well as like the videos, and stay tuned for many more to come. Until next time, thanks for watching.